Good morning, children. This class will continue with our topic, that is climate. Last class we have been discussing about climate and we discussed about introduction, climatic controls and factors affecting the Indian climate. Now we will continue the monsoons in India. What are monsoons? How it will affect the climate of India. We will continue with this.
India's climate is dominated by the monsoon winds. Monsoons are strong, often violent winds that change direction with the season. Arabian traders named this seasonal reversal of the wind system as monsoon. Monsoon has great significance for India. Indian farmers depend on the monsoon rains for irrigation purposes, as it is the major source of irrigation in the country. A great deal of India's electricity is generated by water power provided by the monsoon rains. Monsoon is experienced in the tropical areas roughly between 20° north and 20° south. Monsoon, as you know, is the seasonal reversal of the wind system. There are various factors which facilitate the seasonal movement of the winds over the Indian subcontinent. There are 5 facts to understand the mechanism of the Indian monsoons. The first one is the differential heating and cooling of the land and water. Second important factor is the shift of the position of intertropical convergence zone, ITCZ. Thirdly, the presence of the high pressure area at the east of Madagascar facilitates wind reversal. The intense heating of the Tibetan Plateau is also responsible for causing monsoon. Last but not the least, jet streams also influences the Indian monsoon regime.
Let us try to understand the impact of differential heating and cooling of land and water. Land heats up quickly and cools quickly, whereas the sea heats up slowly and cools slowly. This creates low pressure on the land mass of India, while the sea experiences comparatively high pressure. Let us understand this in detail through the following animation on monsoon winds.
During winter, there is a high pressure area north of the Himalayas. Low pressure areas are over the oceans. Cold dry winds blow from this region to the low pressure areas over the oceans to the south. In summer, a low-pressure area develops over interior Asia as well as over northwestern India. This causes a complete reversal of the direction of winds during summer. Air moves from the high-pressure area over the southern Indian Ocean in a southeasterly direction, crosses the equator and turns right towards the low-pressure areas over the Indian subcontinent. These are known as the southwest monsoon winds. These winds blow over the warm oceans, gather moisture, and bring widespread rainfall over the mainland of India. During winter, there is a high pressure area north of the Himalayas. Low pressure areas are over the oceans. Cold dry winds blow from this region to the low pressure areas over the oceans to the south. In summer, a low pressure area develops over interior Asia as well as over northwestern India. This causes a complete reversal of the direction of winds during summer. Air moves from the high pressure area over the southern Indian Ocean in a southeasterly direction, crosses the equator and turns right towards the low pressure areas over the Indian subcontinent. These are known as the southwest monsoon winds. These winds blow over the warm oceans, gather moisture, and bring widespread rainfall over the mainland of India.
Shift of the position of Intertropical Convergence Zone, ITCZ. Let us understand the mechanism of monsoon in reference to the shift of the position of Intertropical Convergence Zone. The Intertropical Convergence Zone, ITCZ, is over the Ganga Plain in the southeast. The equatorial trough is normally positioned about 5 degrees north of the equator. It is also known as monsoon trough during the monsoon season.
The Intertropical Convergence Zone, ITCZ, is the area encircling the Earth near the equator where the northeast and southeast trade winds come together. It is a low pressure belt and migrates with the changing position of the thermal equator. The thermal equator receives the most intense heat from the sun. Around 24th June each year, the sun is overhead at 23.5 degrees north, the tropic of Cancer. Around 22nd December, the sun is overhead at 23.5 degrees south, the tropic of Capricorn. Hence, the position of ITCZ shifts during the summers and winters. Moreover, the movement of the thermal equator shifts the belts of planetary winds and pressure systems to the north and to the south annually. Therefore, to understand the cause and impact of the ITCZ, we must first look at the trade winds and air masses over India. In July, the ITCZ is located around 20 degrees north to 21 degrees north latitudes over the Mediterranean. It is also known as monsoon trough during the monsoon season. Due to the shift of ITCZ, the trade winds of the southern hemisphere cross equator between 40 degrees east and 60 degrees east longitudes. These winds blow from southwest to northeast and are called the southwest monsoons. In the winters, the ITCZ moves southwards. The reversal of winds takes place from the northeast to south and southwest. These winds are called the northeast monsoons. Hence, ITCZ is a key component of the global circulation system.